Hello everyone. So let's start our next chapter on the topic of random variables. In this chapter, we'll be talking about the difference between probability mass function and cumulative distribution function. We'll also be talking about the relationship between two. We'll be talking about the concept of mathematical expectation, or what we refer as average or mean. We'll be discussing four common population moments which forms a foundation of probability and statistics. We'll be talking about the difference between probability mass function and probability density function. We'll be covering the quantile function and quantile based estimators. In the end, we'll be talking about the linear transformation and its impact on a number of variables such as mean, variance, standard deviation, skewness, kurtosis, median, and interquartile ranges. So let's start our discussion with what discrete random variable and continuous random variable is. Briefly defining or making it more simple, a random variable refers to any quantity with uncertain expected future value. So we talked about event and event space earlier. So a random variable is an event in which we are interested in. For example, if we want to know the probability of rain, then it would be a random variable. The probability of rain on a particular day would be a random variable because the value or the probability of a rain on a particular day would be uncertain. If the quantity or if the probability or if the chance of a certain variable is uncertain, is unexpected, it cannot be expressed in absolute term, then we will be calling it a random variable. So random variable forms a foundation of probability as it tells us that what's the event, what's that particular scenario that we are interested in. Then broadly speaking, there are two types of random variables. Number one is discrete random variable. Now, discrete random variable is a type of variable whose value depends upon the numerical outcome of a certain random phenomena. For example, if we are talking about a Bernoulli random variable, we can have only two options, either 0 or 1. So a team playing cricket would either win or lose. Yes, there can be a draw as well, but the probability of that would be way lesser. If there are parties to which the bank has given loan, it can either be a default or non-default. So we can assign either 0 or 1 to any of these events. Now in this particular case, there are only two possibilities of happening. So there are not countless options. There are not countless probabilities that we are talking about. We are talking about only two events. It can either be 0 or it can either be 1. In that particular case, the random variable is discrete. We have limited, we have definable, we have finite options available for us for which we have to calculate our probabilities. So the discrete random variable is mostly defined by discrete random variable in which the outcomes are fixed. It's not infinite basically. Now the second random variable is continuous random variable. As the name shows, a continuous random variable is a random variable where data can take infinitely many values. So we discussed about the probability of rain. So probability of rain can be 79%, or it can be 79.1%, or it can be 79.15%. So the values that can be assigned to probability of rain is continuous. It's infinite. You can have as many possibilities as we can have. So basically, if it's continuous, if it's something that doesn't have finite options, finite values, then we would be considering it a continuous random variable because the probability doesn't stop. It continues for a finite number of times. Whenever we are modeling asset returns, we have a stock series for which price is available and we are calculating its return. The formula is just to give you an idea, is yt minus 1 upon yt minus 1. So if we calculate this series, the returns would be continuous. So it would be a finite set of values and it can be any value. So operate that way that if we are interested in calculating the probability of asset returns, then it would be a continuous random variable. Now let's talk about the probability function. So broadly speaking, we have two probability functions, probability mass function and probability distribution function. So a probability function explains how the total chance is distributed amongst the possible values. So we talked about the probability function of fx is equal to x divided by 6. Okay. So basically, using this function, we are trying to explain the probability that we can have using a general term, using a general equation.